Hope it's enjoyable for you. So just to jump into it real quick. So client virtualization, here's sort of what most people think about when they think about client virtualization. It's basically a hypervisor running on a PC or a laptop, some sort of end-user computing device. And then you've got the typical layering that you do when you think about virtualization when it's running in the data center. You have the hypervisor, you have the OS, you have the apps, the data, and so forth. And you can have multiple VMs running. But that's only one piece of how we like to think about client virtualization. The real power, we think, in client virtualization is the centralized management capability. So, of course, you have the hypervisor out there on the endpoints, but the real power is being able to control and manage the VMs and that device. So it's sort of like when server virtualization first came out, the main benefit people saw was consolidation of the workloads, right? And people typically used server virtualization in places where they were actually trying to consolidate multiple servers. But what happened over time is, as people saw, wow, it's a lot easier to manage a virtual machine than it is to manage a physical machine. You could do things through software, you could do things through a control panel that you couldn't do without going and visiting the physical servers. And so now, even if somebody's initially planning to run one virtual server on a physical server, they'll typically just throw down a hypervisor just to make the management easier. So the same thing applies in client virtualization. And we actually see a future where every endpoint device just has a hypervisor on it, and you can push and pull down VMs just like you'd push and pull down apps to an iPhone. So with that intro, I'm going to kick it off to Jesus Garcia, our special guest from Intel, to talk about what's been happening with some trends and technologies that relate to and help enable client virtualization.
Thanks, Sean. So if you attended, thank you. So if you attended yesterday's Intel session, you probably saw this slide. It kind of describes the new way that users work. So not so long ago, if you look at, let me see if I can get this to work. If you look at the yellow line, that was the typical work-life balance of a corporate employee. You'd come into work at 9 a.m., work on your PC on work-related activities throughout the day, go home at 5, and forget about work. But today, that's no longer the case. Today, user may get on their PC or on their computer at 7 a.m., check some email, maybe move over to a smartphone, transition and drive to work and listen to email, listen to radio, go back up, work in a conference room with a tablet, and just transition between work-life balance throughout the day, work on different devices, different locations, online and offline, right? So we no longer see this trend of just working from 9 to 5. So this is a good summary, a good graph of what consumerization really looks like, right? And this is what we have to deal with as IT, making these transitions as easy and seamless as possible. And so IT has to enable this type of work-life balance for the users. So in a consumerized world like that, users and IT need to make sure that they are computing with confidence. So what does this mean? So for users, it means that no matter where they are, whether they're online or offline, in a coffee shop, on an airplane, at work or at home, they're working on platforms that enable them to be productive and they can get through the work they can get through the work as fast as possible and be secure, right? IT needs to make sure that the users are also productive and they have a responsibility to keep the business safe and secure while enabling this work life for the user. So for users, that means they need offline mobility. They will not always have a network connection. They need local execution and high performance to get the best user experience possible, right? And they need to do it on secure platforms. IT ideally would have centralized manageability. And why is this important? So that IT always has a pristine copy of the golden image that they can maintain. So if the user does something like gets a virus, gets a rootkit, loses the laptop or misplaces it, IT can quickly get them up and running remotely without a desk-side visit. And you'll see how vPro technologies and client hypervisors will let you do that. Right? It's all about computing with confidence in this world.
Yeah.
So how many people here have heard of vPro processors or vPro laptops?
We still need to
Okay, quite a few of you, not the whole room. So vPro processors are Intel's most high-performing, most manageable, most secure processors for business PCs. They built into the hardware security, manageability, and virtualization features that enhance current software solutions. So I'll give you some examples of some of these features. So for example, intelligent performance. There's a feature called Intel Turbo Boost technology, where the processor itself cranks up the frequency of some of the cores when the workload requires it, so you get better performance when you need it. This is done automatically by the processor. The software does not have to do anything. Manageability. Intel Active Management technology gives IT access to the machine out of band and remotely, so that IT can manage that PC and access that PC even when the OS is off or not responsive. So for example, remote KVM. This is a very powerful solution. IT can remotely control the user's PC as if they were sitting right in front of it, even across reboots. So that when you reboot the machine, you can still see the BIOS screen come up, you can see the client hypervisor come up, you can control all of that, remotely. You cannot do this today with software-based KVM. It's a big, big time saver, great for remote troubleshooting, saves a lot of money, reduces desk site visits. Security features, we have Intel anti-theft technology, AES&I, Intel trusted execution technology. I'll talk about a few of these later on. Virtualization, built-in virtualization solutions like Intel VTX that make client hypervisors like Zen Client possible. Gives you that near-native performance, gives you security and robust virtualization that you need. It's all possible only with vPro processors. So intelligent performance, why is that important? So when users are computing, they want to get through their work faster, right? They don't want to wait for when they click a mouse, to go through for the activities to go through the network and come back and have to wait for things to happen. They want fast responsiveness, things to happen right away. So with Intel vPro processors, you get 4 times faster encryption. We'll talk a bit about the technology that enables that. 80% faster productivity on business applications, and 90% better multitasking. This is compared to a 3-year-old PC. So historically, users did not like to have encrypted machines. When you had a whole disk encryption, you can tell that there was a difference between before the encryption and after the encryption, because you would have to wait for your system to decrypt all of that data and the OS. So Intel decided to do something about that. So they created 6 new processor instructions that help accelerate AES protocols. So what this does is it eliminates that overhead for encryption. So now when you install whole disk encryption products, or you install client hypervisors that encrypt the VMs, the users no longer notice a performance degradation because of the encryption. Right? This is due to Intel AES&I instructions only found on Intel processors. Right? So you encrypt 4 times faster than before. Users no longer notice that performance overhead due to encryption. It's very powerful. Trusted execution technology. So when you have a high secure environment like public agencies, like the Air Force Labs, Department of Defense, right, they need to make sure that the platforms that users are working on are completely trusted. When you add a technology like Citrix Zen Client or Zen Client XT, right, they want to make sure that the hypervisor is secure, the VMs are secure, right, that the whole boot process is secure. So what does trusted execution technology do? It does a measurement of each component of the boot sequence and gathers a known good value. It stores that hash in the TPM, so in every subsequent reboot, it'll measure the BIOS and firmware, the hypervisor, and compare that new measurement with the last known good value. So in the first case on the top, it's the positive case where you reboot the machine, it measures the firmware in the BIOS, it matches the known good value, the hypervisor measurement matches the known good value, and so it allows the launch sequence to continue, and you get the full, the VMs coming up, and users start working. The case in the bottom is when the hypervisor, let's say, has been modified, unaltered. So the system boots, the firmware and BIOS match the last known good value, but the hypervisor, maybe the user accidentally installed a rootkit like Bluepill, the hypervisor has been compromised. So the new measurement does not match the last known good value. TXT detects that and blocks the booting of the rest of the system so that the user now can no longer use the system because it has been compromised. Very, very powerful solution for high security environments like we see in public agencies with the government. Zen Client XT currently takes advantage of this technology, right? Only brought to you by Intel vPro processors. With that, back to Sean. Thank you.
Great. Thanks, Jesus. Okay, great. Thanks, Jesus. That was a great description of some of the Intel technology that is used to power some of the client virtualization work that we're doing. So I'm going to go through these 10 use cases that I think are pretty different from what most people think about on client virtualization. So actually, I was going to say that basically, if you look at these use cases, they really are around laptops and PCs, right? And so, and there's been some talk about PCs being dead, and it's not, right? So this is data from some of the analyst firms out there that show growth. So overall growth of PCs, when you look at both PCs and laptops together, over 7%. And when you look at laptops in particular, it's double-digit growth. So definitely a lot of growth happening here into the future in the PC market. Now, yeah, it's definitely true that people are using more tablets. They're using more there are different devices like phones and things like that. And it also is true that in certain markets with consumers who actually probably never needed a PC anyway, they might not buy a PC because they can get away with using a tablet. But for people that are doing real work, PCs are not dead. So laptop virtualization, the first use case. This is actually one of the first use cases people think about when they think about client virtualization because you want the benefits of desktop virtualization. A laptop is great, but it's not always connected. You don't always get a good network connection. And so having a laptop that can run a virtual machine, you still get all the benefits of virtualization, but you can take that with you to go, right? And so the approach that we follow actually is a little bit different from check-in, check-out types of models where it can take quite some time to do a check-in and a check-out. The approach is continuous synchronization. So even if you wanted a hosted VM or if you wanted to be able to access that data remotely, even when your laptop's off, you continuously synchronize the information. And so you don't have to sit there and wait for a check-in or a check-out in order to just take your laptop and go. So that's the first use case, probably the most thought of one for client virtualization. So the next use case is around data protection and security. So Jesus talked about a couple of things around trusted execution technology and trusted boot, but there are actually a number of different additional security capabilities that are built in. So, for example, Jesus also hit upon this one, full disk encryption. So first of all, the desktops are secure because they're completely isolated. We use a Type 1 hypervisor. So it's a true Type 1 hypervisor that doesn't have an OS underneath that hypervisor. There's ways that you can make a hypervisor look like it's like a Type 1 or a bare metal when it's really not by putting some sort of a hidden OS underneath it. This is a true Type 1 hypervisor. It's based on Zen. Gives you the level of performance and security that you get out of any Type 1 hypervisor, which, by the way, it's the only type really that's used in the data center. You're really using Type 1 hypervisors there, and that's for a reason. So that gives you direct access to the hardware. You can get the complete full disk encryption. You also have features like time-based lockout, so a VM can disappear if the user doesn't check in a certain amount of period of time that you can configure. You have configurable USB filtering, and you can do that by virtual machine. So if you had more than one VM on the PC, you can say, well, this personal one, you can access mass storage, but for this corporate one, you can access USB devices like headsets or cameras, but you can't access mass storage because we don't want you to offload your data. Different policy controls you can set up for those USB drive access and other policies like power management. You can control all of that centrally. Remote kill, so if your PC gets stolen or your laptop gets stolen, you can kill it remotely, and that can be done over HTTPS. So even if the machine, as long as it touches the internet, it'll pick up the signal and perform the remote kill. That does a 7-level wipe of its drive. And then secure automated backup. So there's transparent automated backup capability built in to protect the data itself. Third use case, so how many people have deployed a large number of PCs into your infrastructure in the last, say, 3 years? How many people would want to refresh your PCs right now, but it's just going to be too much work to actually do all the work to get those PCs refreshed? Okay. You know, I think one of the challenges that you do have when you do a PC refresh is, you know, you have to figure out some way to get the machines out there, how to get people's images moved over. With a PC refresh, when you have a hypervisor down, basically you just update the image and just hit refresh, and you can roll out thousands of PCs. Just click the button and it goes. You can actually get the client hypervisor pre-installed from a number of different manufacturers. So you call up your PC manufacturer. You know, Lenovo's been doing this for a while with us. You just call them up and say, I want the Zen Client Enterprise pre-installed on it. You buy it, you get all your units. It's got the hypervisor pre-installed, gets registered to the synchronizer, and all your VMs just synchronize right out. So you have a zero-touch deployment. You can deploy thousands of PCs just by assigning them out. So that capability also empowers something else, which is if you have a machine. So where I used to work before, if I wanted a new laptop, it was a real pain because they'd have to take it away and do all this junk, and then I'd have to lose it for all this time, and I'd get it back, and it wasn't exactly the way it was, and I have to reset up some stuff. So one of the benefits here is, say I have this older laptop and I want to migrate to a nice new Ultrabook. Okay, no problem. It actually, so I've done this, and it takes about 10 minutes. So you just, you know, have your IT person just unassigns you from this machine, assigns you to a different machine, depending on how much data you have to transfer, because you know that part can't be reduced if you have data to be transferred. But your VM will just move right over, and I literally just went, had a cup of coffee, came back, and it was there. And the cool thing was, when I opened up my start menu, all my recent documents that I was using before was still there. My desktop icons, they were all still where I'd put them, and it was just like I just actually even had like my Google Chrome had tabs that were open and up when I left my PC, and those were still like that when I came back. So it was actually pretty awesome. So the next use case is instant recovery. So say you're walking down the street and you know, you slam down your PC on the ground and it breaks, or suppose you're surfing something, or one of your users is surfing something and they click on a virus, and it's a newer virus, so your AV software doesn't capture it, and they end up having some malware. Well, in the case of malware or corruption, you can set up something called snapback, where it boots to the clean, pristine image. So you just reboot, and the virus is just completely eliminated. So that's great, because if you have users that are on the road and they don't know what to do, you just hit reboot, and most of the time you can just get rid of any issue that came up. The other thing that's pretty neat about that is Windows images can tend to get gunked up over time, and so start out with a fresh image and it's great and it's fast, and then over time it gets kind of gunky and slower, and it's not as fast as your fresh Windows install. With Snapback enabled, every time you reboot, you get that fresh Windows image the way it was, and your user personalization and stuff are stored in different layers, but your system disk for your Windows is just like it was, so it boots really quickly and it performs really quickly. And then, of course, if you physically destroyed the machine, you can migrate to a new one. So you're looking at that migration scenario we talked about before. Now, in terms of managing PCs, this is a great use case. We've actually seen some companies that use this approach for their entire PC management process now. And they've actually seen dramatic decreases in costs, both in the management and also support costs, ranging from 50 to 75% is what we've seen. And where it comes from is, first is this one-to-many image management. So the ability to fire up an image in the console, and literally you're managing that PC as if you were just managing a single PC. You do whatever you want to do to it. You fire it up, you install a patch, or you install a new application, hit save, you publish it, and it just automatically goes out. You don't have to do anything else other than hit publish, and the VMs, the endpoints will automatically pick up the VMs that were assigned to them, and you're all set. So zero failure patching, same thing. If you put a patch out in a normal environment, that patch could interact with other applications or things that are on that PC and potentially fail. So typically there's, and it depends on the organization, from anywhere from a 3 to 8% patch failure rate. You can see when you do large deployments of patches. This way you can test the patch completely, make sure it all works, and then deploy it, and then it's going to be consistent across all those machines because it's a virtual machine. And if you do forget to do certain testing and you roll out a patch, you can actually roll it back. So this is something that's actually incredibly difficult to do in a traditional environment. If you roll a patch out and now you decide, oh wait, I didn't want that, I have to try to undo it. There's not really an undo button. But here it versions your different VMs. So if you roll a patch out and it doesn't agree with something, you could just click rollback, one-click rollback. So we talked about the instant virus corruption recovery. So integrated remote support, there's also the ability to get to the hypervisor. So even if the operating system has blue screened, you can still get to the hypervisor through remote support capabilities and take over that PC and manage that PC. We talked about migration. And then security, with the encryption lock and kill, that's also a savings as well. If somebody loses a PC, the typical cycle is you want to make sure that data was protected, you want to try to kill it, and then you want to get them onto a new machine as fast as possible. So this is a great use case actually. So if there's people that have labs or training centers or any set of machines, public libraries, corporate libraries, any place where there's sets of machines that lots of people come and use those machines. And basically, so one of our customers said it to me like this. He said, it's kind of like if you want to drive a car over a curb, you get a rental car, if that's what you want to try doing, or if you want to try to, shift the gear while it's going. I mean, this is what people do. It's not their own thing, right? They just don't care. So they'll click on anything, they'll download anything, they'll install anything. This is what tends to happen on these kinds of PCs, and they get really gunked up. But you can set an automatic reboot schedule and any frequency that you want, whether it's overnight, whether, if you have class schedule in between classes, you can set up reboot schedule so it automatically boots to a clear, pristine image of whatever you've defined every time that it reboots and you're good to go. You can also use it to create different images for different training packages or different things that you're working on. So if you want to train somebody on one set of applications or packages for one class and then another for another class, you can have multiple VMs that you can use for that. So, remote access, this is actually a brand new one here, and Gabe Correjo is going to talk about this a little bit more. We're going to dive more deeply into this. But if you think about VDI or, what people think about desktop virtualization, there's really 4 key benefits you get. So one of them is security, right? So we talked a little bit about security here. In the VDI model, it's by putting the data in the data center. In this model, it's by using full disk encryption and some of the other capabilities that we talked about, time-based lockout, remote kill, USB filtering. So that's one, security. The next one is manageability, which we talked about a bit. The third one is reliability. So in the VDI scenario, it's being able to quickly just move to a different client or terminal and be able to access your VM. Here, it's being able to quickly migrate to a new machine or to reboot to a new clean golden image, so you get that kind of reliability. So you got security, manageability, and reliability. The fourth one is remote access. With VDI, you can go get your machine from anywhere. So this one closes the loop on that. Now you can remotely access your PC from anywhere, from your home computer, from your iPad or iPhone or Android tablet or Android phone. So it's great, and Gabe is going to do a demo of that for us. So the other one I wanted to highlight was resiliency, right? So what you could do is use, we actually have some customers doing this. They'll use Zen Client to access their VDI sessions for certain applications. And that way, and then they'll put the certain applications actually in the Zen Client as well. So they'll have a local VM. And so if they have a network outage or something like that, people can use local applications to do whatever work they're doing and then have that synchronized back. But they have reason to use VDI because they want to keep a hot session running and have people move from room to room. This is a good scenario for healthcare. So they actually wanted to use VDI because it keeps VDI's a good value prop is that if a doctor is moving from room to room, their session stays live and they're just popping into it from different places. But here they can use Zen Client to access the VDI sessions, and therefore if something ever goes down, they can at least use the local copy. And the last one is anytime, anywhere access, right? And so we talked about remote access, but what happens if your laptop's actually off and it's in your bag, it's going to be kind of hard to remote access that, right? So what you could do is you can have profile synchronization. So you just grab a VM from a VDI session, and you then have that VM, and use profile managers so that your information is pulled off centrally stored information. It's always synchronized there. And you grab a VM, you do what you need to do, you use your applications, you save it, and then when you pull your machine back up, it just synchronizes your profile back up again when you're ready to work on your laptop again. So that's an awesome use case where you can use VDI to complement a deployment where you may deploy client virtualization everywhere. So, in this use case, you only need a small number of VDI VMs because you only are usually using the VDI VMs when, you're in this kind of a scenario where your computer is put away and you need to have some, quick remote access. So 10 use cases. I kind of lied, though. There's actually one more, right? The bonus use case, which is funny because this is actually the use case that most people originally thought about for client virtualization. Say, when people came out with workstations that you can use, say, well, this is great for me to be able to run multiple VMs, and I can now put more than one thing on there and use it for testing and deployment, and I can play around with all that stuff. So that was probably the original use case that people came up with, and we actually talked about 10 other ones that are beyond that original use case. And with that, I'm going to pass it off to Tom Reed, who's going to do a deeper technical dive into Zen Client.
Thanks, Sean. So we're going to talk about a little bit about what the architecture looks like on both the client side and the server side. We're going to talk a little bit about what components are what fits in where, communication, things like that. For those of you that don't know me, I came over in the virtual computer acquisition. I was director of sales engineering for them, and now I'm going to take a similar role here for sales engineering for Citrix, focusing solely on client virtualization. So, first of all, what's new? Why the acquisition? What actually took place? And what was going on here? Zen Client, or Nextop previously, is now known as Zen Client Enterprise. Zen Client Enterprise has a much larger market now than it did before the acquisition. Bigger policy controls, more in-depth management, much larger HCL, okay? Some role-based administration stuff, the ability to manage everything through policies. I got to keep bringing up bigger HCL. Okay, we're going to talk about that. So not much has changed on the architectural standpoint. Still based upon Zen, still leveraging HTTPS or SSL for our communication back to the management server. Still working very closely with Intel, like I stated last year at this conference, very, very tight with Intel. Obviously, Jesus is with us and can get deeper into that at the booth later on. Still a fully virtualized platform, which brings us to our first change. Currently today, in the product, there is no GPU pass-through for 3D graphics. There will be soon, okay? So what we've elected to do is we've elected to take the best of both worlds, the best of the Nextop product, the best of the Zen Client Classic product, and put them together. Some of that integration has already begun and is already available in the release of 4.1 today. Over time, you're going to see more and more integration of that come together and really grow this platform out. Wide range of business class PCs. Thousands of endpoints supported. Now, we use the term PCs here. I know Sean talked about some of the use cases around laptops, not just for laptops, a lot of desktops in production with this product today. Okay? Fully shared image support, Windows 7, Windows XP, Windows Vista, 32-bit, Windows 7, 64-bit. Some Linux support, more coming down the line. Okay? It's a power virtualized platform. A Lenovo looks like a Dell, looks like an HP. All the same, one image across the board. The way that the operating systems are actually managed, we rely heavily on the virtualization technologies such as VHD disk chaining in order to provide one-to-many patching. So for example, Sean mentioned a use case about viruses, spyware, and malware. Simple reboot cures all that. Well, that's because when you're in session, you're not actually writing to the system drive. You're writing to a differential disk. When that system VHD comes down, it lives and executes locally on that endpoint, whether it be a desktop or a laptop, that stays there. Now, as you patch and maintain it, you're doing all that on the central management server, and then you're pushing down those block level differences down to that local VHD. Leveraging VHD disk chaining, we have the flexibility to one-to-many patching, one-to-many rollback. For those of you that knew us as Virtual Computer, we had Next Up Center. Next Up Center is now known as Zen Client Enterprise Synchronizer. Okay? It's very similar technology in terms of what we're doing, what we did before, what we're doing today. We still leverage Microsoft Hyper-V. So I'm going to talk about that for a second. That's important.
Go
We
away.
use Microsoft Hyper-V to
Seriously.
boot the images up to patch and maintain them. You don't have to know Hyper-V. You don't have to ever go inside of the Hyper-V console. It's all done inside of the synchronizer. Okay? So with that being said, we have production customers that are doing it today. It's not uncommon. They can use ESX, Zen Server, or Hyper-V to put the synchronizer inside of. And then they're deploying a small laptop or desktop on the side that runs 2008 R2 server with the Hyper-V role enabled. Because literally the only time you're leveraging is when you boot up that VM inside of the console to patch or maintain it or do some changes to that virtual machine. So it's not a constant tie to Hyper-V. There's no reason that you can't move things back and forth out of your management, leveraging ESX and things like that, HA, fault tolerance, all that fun stuff that's inside of your server virtualized world. You can take advantage of that with the management software. We use a SQL backend database, very straightforward there. LDAP connections. We don't extend schemas. We don't make major modifications to Active Directory to jam ourselves into it. We do a simple LDAP read. All of our LDAP filtering is done on the domain controller rather than on our management server. Domain controller has all that stuff indexed. It's a lot quicker. It's a lot cleaner. Leverage the processing power you have today. When you assign a virtual machine to a user or to an endpoint, we then import that LDAP connection, that user, SID GUID, no passwords. We do not import passwords. So we import SID GUID into our SQL database. That allows us to track things like the backups. So we know what user's backup goes to what user. It allows us to have the flexibility to also assign policies to individual users when they connect to their endpoints. So the backend system, we talked a little bit about this already. Again, that authoring server, we're going to call that. Moving forward, 2008 R2 with Hyper-V, and then that management server, again, can be whichever way you want to put it. We have the flexibility also for what's called remote caching servers. If you have a enterprise-type deployment where you have multiple offices, multiple locations, maybe there's 100 people, 50 people in an office, we don't want those 150 people to go ahead and push back HTTPS connections back to a central location. Rather than do that, you deploy a 2008 R2 box, no Hyper-V role, can be virtual, can be physical. That services the clients at that location. So then only one connection is made back to the central server over SSL. That's block level difference communication, again, between the two. All communication is SSL, all communication is block level differences. 2 ports need to be open for that to function, 443, and today's SQL Server 1433 as well. 1443? No, 1433. That's a typo on the slide. Obviously, the port is customizable, though, so we could say it's a typo. We could say we recommend going to a different port. We'll go with whatever works better. All right? But it's actually for you guys, we all know 1433. But like I said, we can go either way with this. Again, it's really nice to have this. Now, this isn't necessary either. So if you have a small office, 10, 15 people, chances are you're not going to deploy a remote server down there. You can just let them come back over your WAN, MPLS cloud, wherever it may be, and communicate back. There's bandwidth policies for everything. So you can actually state, you know what, between the hours of 9 and 5 or 8 and 7, Monday through Friday, I don't want any more than 5 people connecting to my management servers. I don't want to use any more than this amount of bandwidth. So you can actually aggressively limit what's happening in terms of bandwidth control. And I think that's very important because there are times when, especially around lunchtime, everybody starts to use the internet for their personal use and things like that.
15-minute session.
So a couple of key terms here now that have changed over. The engine is still the engine.
40?
Okay, so we're going to continue to call that. Again, like Sham said, type 1 hypervisor sits right directly on the hardware. One nice feature here, and I think it gets a lot of play when users go through proof of concepts, that hypervisor can be completely hidden from the end user. The end user has no idea they're running on Zen client. They can simply log in and boot the machine up, and they'll go right to their Windows screen, and they can log right in. The only way they would know is if they're using our AES-256 disk encryption. There's a splash screen that comes up upon boot that says, you got to unlock the disk. So you got to put your Active Directory password in, unlock the disk. That's when they would know. If they want to go ahead and they want to change their wireless connections, things like that, because we're power virtualized, our networking is all done at the hypervisor level. There's an icon in the system tray. We released this last year. It's still one of the favorite features out there, that you can actually go ahead and it will bleed through Windows. So they never have to go into the hypervisor to change your networking. Okay, so for me, for example, I switch from a 3G modem to wireless when I'm on the road, depending upon where I am. I never have to go back down into the hypervisor to make that change. It bleeds right through. It is a different looking control panel. Once you see it though, once your end users see it, they kind of like it a lot more than the Windows one. A little bit of a splash screen here, not much has changed here. We went from gray to blue. That was nice. So now we're blue here. We're blue on the synchronizer as well. Colors match. As you can see, pretty standard, straightforward interface there on the UI side. A couple of things in the synchronizer. For objects, users obviously, groups, AD groups and users, same thing. Virtual machines, your policies, your software, your computers, and then you can see all your events on your endpoints. You cannot see inside of the Windows logs. These are hypervisor events that you can see. Everything is stored back in that SQL server, so you can run reports on utilization and things like that if you want to go inside the SQL database and leverage a third-party tool. We revamped Active Directory. Before, if you recall, if some of you have used it before, we had a very flat AD. Now, I think it's on the next slide. We took it out. Uh-oh. We actually give you an OU structure look, so you can actually see all of your OUs inside of our control panel. So there's no need to go ahead and rewrite things over, okay? Before in the past, we had a very flat look where we just imported everything. Now, again, you select the OU and then you go ahead and pull from the OU you want to pull from. So talk a little bit about how our layering is going to work and how things are going to function here. Obviously, that system VHD comes down. That's your first version. As you continue to build that up, version 2 then becomes the top of the chain. You read down in VHD disk chaining. So you always read from the top down. If you write at version 3, that's where your write sits, okay? So your write will sit there. And what's beautiful about that is when I say you read down, you'll hit it going down through the chain. Version 4 obviously becomes our current version. Sham had mentioned we can roll back. Should something happen, let's say we push a patch out in version 4 that it's got a problem. We didn't test or account for stepping on a DLL inside of an application. We have the flexibility to simply click one button and actually push it back to version 3. Keep version 4 because it is a VHD chain, so when version 5 comes out, we have to have that flexibility. Roll it back to a single thing. Talked about the snapback VHD. When you're in session in a shared virtual machine and you're working inside of there, all of your data is written there, with the exception of certain things. There's a U drive and an L drive. User VHD, a local VHD. The user VHD stores user-specific profile information and other items that you want to back up. The local VHD stores items you want to preserve across reboot, but not back up. Why bloat our backups with things like Outlook OSTs? That's recoverable data. It's an offline cache. I don't want to back that up. There's no point. I don't want to back up my temporary internet files. So we use Symlinks under the cover to actually go ahead and move things over. So in DOM 0, what we actually do here is we have 3 separate VHDs. We then move things upon a reboot. I'm sorry, as a shutdown, we preserve the data over to where it goes. So the symbolic links are copy on write symbolic links. So when you put data inside of C:/username, %username, my documents, it's actually a copy on write symlink over to that U drive. That U drive, again, can be backed up, snapshotted on a block level, different type scenario. We discard at that point that snapback VHD. That disappears. So anything that makes an unauthorized change to the C drive, such as something in the registry, something in HKey local machine, current user, log on, whatever the case may be, that's going to be stored in that snapback VHD, and that's just discarded upon the reboot. When we boot the machine back up, that snapback VHD is recreated fresh from scratch, and then we go ahead and mount the disks and then copy the data back to where it belongs. Okay? Because we use symbolic links and pointer records, that's actually quite a quick process. The beauty part about this process, it's seamless to the end user. They have no idea this is happening. So if I sit down on my machine and I change my wallpaper, if I save something in my documents, I'm saving it how I normally would today. This is all behind the scenes under the covers. Okay? The other thing that's nice about it, it's completely customizable. It's a simple XML language to state, I want to preserve this, I don't want to preserve that, I want to keep this, I don't want to keep that. Same thing for the registry. We simply go ahead and do the same thing with a flat file registry key. That's how we preserve that. Out of the box, this question seems to be coming up year after year. What's actually stored out of the box? And there's some examples here of out of the box, what's put where. With the only change here, This folder I recently found out is no longer called C:/nextstop, it's C:/citrix now. That's a hidden folder where a lot of the log files are stored. Program data, things like that, again on that new drive. Things like prefetch, temporary internet files, your page files, stuff like that. Again, it's still stored on that L drive. We really don't want to bloat those backups too much. And when I say the backup, it's important to note that this backup is not a replacement for like a CDP type technology. If you have a requirement where your users are changing data every hour on the hour, that's not what this is designed to do. This is designed to give you rapid recovery should your machine blow up in the middle of the day. Okay? It's actually happened to me about a week before last year's BriForum. I told this exact story at BriForum. My hard drive just died, and I pretty much lost my presentation for BriForum. We had to go back to my last known backup, which had happened 2 days earlier, and go ahead and restore my entire machine down. All in all, it's about 35 minutes on our LAN, and that's a gigabit backbone. I got my image, my last known backup, and I was back up and running, no problem, no questions asked. Again, that registry state, we keep it in 2 locations, the U and the L drive. You know, it's kind of one of those things where everybody says, well, how do you mount it? Mount it just like everybody else does. It's a flat VHD file, a flat virtual file that gets remounted back in the registry hives. Your image management, again, we now have the capability, and I know this came up last year, the year before, and many other years, to dynamically regrow your disk after you've already deployed it. Before, we would set you in stone onto what you do. Now you can dynamically grow that disk and change it on the fly as to what it needs to be as things come around. 3 basic types of policies: virtual machine policies, engine policies, synchronizer policies. 6 policy types. A lot more robust than the old synchronizer. You got your engine policies. Do I want to hide the hypervisor? Do I not want to hide the hypervisor? Do I want single sign-on through to the hypervisor? Do I want to be able to pre-configure the wireless, for example? You can pre-configure all your wireless with WPA2 Enterprise, WPA2, Web, TTLS, TLS, MS Chap, all the great ones, generic token, the works. So you can pre-configure all that before your endpoints go out to your users. OS profiles, those are the guys that do the symbolic links back to the U and the L drive. Your lockout policy, pretty straightforward policy, right? Lock them out if they don't check in with the endpoint. See, if you have users that don't check in for whatever reason, you can go ahead and lock them out until they do check in with the server. The other thing, if you never set that policy, your end users never have to make a call back to the server, ever. Backup policy, again, how often do we want to back up that U drive? How long do we want to keep it on the server for? And then when do we want to start a new, fresh snapshot tree? USB filtering, we're going to change the name of this actually. We made a decision yesterday. USB firewall, it's really what it is. We're blocking devices or we're allowing devices. And this is by device class. In the future, it's going to be device class ID. And then expiration. Another great policy, you know, I want to use a VM for 30 days for a consultant. After 30 days, I'm going to go ahead and expire that virtual machine out. Very straightforward there. Our encryption architecture. The boot device has an unencrypted partition where we go ahead and we go to the control domain and unencrypt. The key management is in 2 places. The first key, when I register myself as a user, my Active Directory password creates a key in the background that is tied to my AD password. Okay, so my AD password is what I get to unlock the unencrypted partition to get into the control domain. That key goes through TPM, and the next thing I know, I've unlocked the disk. The second key is created upon registration. That key is stored escrowed in the SQL database on the management server. What's nice about that key is I forget my Active Directory password. I've been on vacation 3 weeks. I forget what it was. We get a policy to change every 30 days. I call IT. I say, I need you to get me into my disk. They can read me a password over the phone. It's quite large, and it's really ridiculous to actually have to read or write down to somebody. That's by design. But once they put that 15 to 30 character string in, it unlocks the disk for them. Then they can get to at least all control delete and then have to go ahead and start from there. It's also nice, should an asset be recovered, an employee is terminated or something like that, you don't want to reset their AD password for whatever reason, you can then go ahead on in and just use this to unlock the disk and then use a local admin password to get into that virtual machine. Remote kill. Great feature. Like Sham said, this can happen over the web. If the endpoint gets a network connection, because we use SSL 443 is open back to our synchronizer, we can go ahead and make a communication back. It's first going to shred any encryption keys so that the encrypted boot can't be read. It's going to delete all the virtual machines, and it's going to write random 1s and 0s across the physical disk. The system's halted after about 30 minutes of that, if the system's not already halted at that point. One of the nice features about this, you can recover the backups on the server are not affected by this. So should an asset be stolen or a user gets terminated, takes that asset with them, you go ahead and wipe it out. When you want to, you can get a machine back in your office, change your AD password, log in as them, it's going to get their last known backup. You still have access to all of their backed up data, so you can still see everything. It doesn't affect the backups, it only affects the endpoint. Again, that user data backup is all done as a policy, custom XML language on how to get there, personalizations. Pretty much anything that a user does is backed up. We want the user experience to be the exact same that it's always been their entire lives. So we were very critical on that, on what we back up and where we put things.
Around 10:50 then.
The snapshot is created on a scheduled backup. We pause the guest, we add a new differential disk, we update the guest to use the new header, and we resume the guest. All happens so fast you can't even blink your eye before it's done. The user has no idea this is all happening in the background. We then send a user diff M1 back, and once the backup is sent, it's merged to a single VHD. Okay? Once the backup is sent back to the synchronizer, it's no longer on the endpoint. So you could not roll back. They have to take that backup back down. So once it's uploaded, it's off the endpoint at that point. It's been merged to a single VHD up on the endpoint. That's the bulk of it all. Gabe's going to talk a little bit about remote PC.
Thanks, Tom. Appreciate it. I feel like Darth Vader with these things on me right now. Hi, everyone. I'm Gabe Correjo. I've been with Citrix for almost 8 years now. And I'm going to talk to you about a solution that we just recently announced at Synergy in May, and then released to web as part of Zen Desktop Feature Pack 1 on June 29th. And that is Remote PC. So I put the hashtag up here if you want to talk about it. I'd love to see more tweets about this solution. So Remote PC, just to kind of give you a flavor of where it fits into our product portfolio, is the physical option here of the different types of ways that you can deliver a desktop. And Remote PC was brought to the world, if you will, in order to take advantage of some challenges that exist out there today that have been there for a number of years, over a decade. How many of you have users or know of companies that connect via VPNs and maybe use the RDP application to connect back to a PC internally? I think pretty much everybody's hand is going to go up here. How many of you found there were challenges with supporting VPN tunnels, maybe some performance issues, and wanted to broaden device choice and maybe leverage Citrix technologies to publish that same application? I did as an admin in my previous years. So you have different types of access methods to traditional or physical PCs sitting in the cubicles. You may have realized one benefit over another when you deployed the solutions, but at the end of the day, you still had some challenges with either or. So we brought Remote PC to the market 3 weeks ago in order to provide an end-to-end, fast-performing, zero administration experience for your users and you as the administrator. So I was also challenged on how am I going to create a technical overview of this solution when it's so darn simple. And the reason it's so darn simple is you install our broker. We shipped a new service with it called the Remote PC service. This is an add-on to the Zen Desktop 5.6 broker. It's just a service. It's optional. You don't have to put it on your broker if you don't want. And it'll go out there and it'll look for the desktop soft-registered agents and add that PC to a desktop group catalog and assignment. And then the next time the user logs into their PC, it maps the user to their machine account. Okay? So when they log into web interface, cloud gateway with storefront services, the icon for their PC automatically shows up. Help desk wasn't involved. IT didn't have to get in the middle of all this, and the processes and heartache with providing access to physical PCs has been eliminated. Now, this Remote PC VDA is the shipping VDA that is now part of Feature Pack 1. So if you download it to test it out, it's just going to say the updated virtual desktop agent. This has been re-architected so that it allows for a work local, work remote type of scenario. So proper monitor screen blanking, multi-monitor support, being able to respect the local WDDM display adapter without having to retest applications with what our agent does on that physical PC. We don't replace the display adapter locally, we work with it. And lastly, your users go out and get the receiver on any device that they would like, okay? So to build a technical overview of this solution would be a little bit challenging in that there really is nothing too technical about it, okay? You install the broker, leverage the remote PC service if you want to, throw in an access gateway in the middle, and you've eliminated VPN tunnels, and you're now using HDX end-to-end from the receiver to the physical PC in the cubicle. It's an extremely simple solution. I've gotten a lot of great feedback and a lot of awesome blogs. Thank you, bloggers. I appreciate that. And you know, it's such a simple solution that I think it gets glossed over a lot of times. There's a lot of value when you start to add it beyond just traditional computing, though. But let's take a look more in depth about this service. So the service is, again, is a MSI that you would download and you would apply it to the broker. And basically this service is just a XML configuration, and at certain periods of time it looks at a PowerShell script to run your configurations. So you don't need to go into the studio to manipulate deploying a remote PC solution. It's a console-less solution. You manage the XML file one time and then you're done. It's like Ron Popeil, set it and forget it, right? The chicken's roasting, let it roast. So that's the whole premise of this solution. And the XML file itself looks at the service starts up automatically, it reads the configuration file, and then it makes those determinations of where that PC should go within a catalog and assignment. And then again, the next time the user logs in at the PC itself, it maps the username to their computer name. Now, this is a little bit of an eye chart, so I'll let you look at it later on, but this is an example of the configuration file. And when you download it and install it one time and edit it one time, there's 3 changes that you need to make. You just need to set that to true for enabled. You need to add your catalog name, desktop groups information here. And then there's an asterisk that is in machines excluded. You don't want to exclude every machine from running this, so you want them to actually be collected and managed. So you remove the asterisk, this is there. Start the service up and start deploying your VDA pointing to the broker sites, and you're good to go. Everything will just start working automatically. Hello? Okay, so that's remote PC at its very basic nature. Now, when you look at the whole desktop delivery model that we can provide, you've got Zen Client Enterprise all the way on the right. So we want to talk a little bit more about client virtualization in combination with secure mobility. Now, you've seen this slide from the earlier presentation, or earlier in the presentation, and I'm going to add Zen Client Enterprise that Tom and Sham, everybody's talked about here prior to this. So I'm putting the VDA into the image. Without Zen Client Enterprise, I'm still managing and delivering the image at the endpoint. I'm not actually centralizing anything here. I'm taking advantage of HDX technologies. I'm eliminating VPNs and RUP, et cetera. And I haven't really done anything to begin that process of migration, if you will, and ease of management. So my image delivery management still stays at the endpoint even though you've deployed remote PC and your users are loving it. You want to be able to integrate that solution into a desktop delivery mechanism. So with Zen Client Enterprise and using the local option, that image is now delivered from the enterprise data center out to the endpoints, but you're still accessing them securely at the cubicle itself. And it's so simple. I hadn't looked at Zen Client Enterprise Nextop, if you will, prior to a couple of weeks ago. I downloaded it in about 2 or 3 hours. I had figured it all out. I installed the remote PC or the Zen Desktop VDA into my image, and there are a few nuances, and I want to share those nuances with you on when you go out and try this yourself. But I did have to go ahead and make a special engine policy. So Tom talked about policies itself. You can modify the default one, but I just thought it'd make it easier just to create my own. And the engine policy is so that I don't allow it to log in, if you will, as a pre-configured user. I want to have that prompt come up for a user logging in locally, and then I don't want to show the launcher. I may deploy this solution to thousands of machines that they originally only had one image on them. So why am I putting 3 or 4? But you're still having that benefit of central image delivery to the endpoint, but you don't necessarily need to see the launcher for one VM. Oh, I'm sorry, this is where the manual logon piece is. I don't want to auto log in to the VM itself. And then lastly, here I've got, what do I have here? Oh, this is me just determining the prior 2 screenshots that I showed you. So with that, I have witnesses that saw this working twice before I came here. So I have my desktop PC. Let's just pretend that's what it is here. And I'm going to just show that I'm using it locally, so I'll sign in here. And everybody can see I've got my desktop. I'll just pull up my remote PC PowerPoint. And you know, I want to be able to take this. I have an activated Office, as you can see. I want to be able to take this desktop with me. So here I've got my iPad and got my receiver, my icon, and Remote PC again was built so that it blanks the screen locally and it transitions the image and representation of the OS to my handheld device. So I also have, oops, I tapped the wrong icon. I also have my phone. So not only does, you know, a tablet make sense, you know, the BYO, different types of devices, I've also got it on the cell phone. So cell phone, not very practical, but at least I can take it with me and continue working on things. The image is centrally delivered, centrally managed, okay? If I were to come back to my desktop here, hit Control-Alt-Delete, the desktop disappears from whatever tablet I'm using or device. I log in again, and I continue working as if I was coming back from a meeting down the hall in a conference room, going to lunch. I want to continue reviewing that video or working on that email, come back, and I don't have to be constrained as a user by my physical desktop, okay? And just to show you this was not smoke and mirrors, this is my launcher here, okay? So that VM is delivered and managed centrally from Zen Client Enterprise. So that is the end of my segment, I believe, and I believe the end of everything. Shyam, did you want to close things up? Oh, I wanted one more thing I did want to clarify. I attended a session yesterday, and we do still support streaming to endpoints with provisioning services. That is in the Zen Desktop family line. So it hasn't gone away. I just want to re-clarify that. And you want to see provisioning services with remote PC to an endpoint, come over to the Citrix booth. I'll show you that as well.
So I think what I want to do is just end it a little bit early so it takes some opportunity to answer some questions. Does anybody have any questions around remote PC or Zen Client Enterprise or anything that we've seen here?
On the Zen client, are you married to the L and U drive mappings, or can those be changed?
Yeah, so those can be changed. They don't have to be U and L. Most customers do change them out of the gate. Absolutely can be changed, very easy.
Yes, with the automated assignment in remote PC, like what if I'm an administrator, I go to 15 different machines trying to fix this and that? Is there some kind of...
Yeah, you don't have to enable the service if you don't want to. You can just do it with manual mappings if those machines.
So is it per user, or is it?
It's per user, that's right.
Okay, so it's not per machine.
Correct.
Okay.
That is correct.
My question is about some use cases that didn't come up, and I just kind of wanted to get your opinion on them. The two that we see type 1 technology being good for is, of course, BYO and mergers and acquisitions. And in both of those situations, we already have an operating system on that device that we don't want to destroy. What kind of roadmaps do you see to be able to do the P2V and slide the hypervisor underneath? And then even more important than that, how to bring it back to its original state with a V2P conversion?
Sure. So the sliding of the hypervisor underneath has never been successfully done. There was at one time a company that claimed they could do it. They are no longer in business. Nucleus, actually. From what we understand and what I've heard from past and present employees, both at Nucleus, past employees there, as well as others in the field, it was never successfully done. The best option today is a dual boot scenario. P2Ving, when you P2V, you know, there was about 2 years ago somebody said, well, I'm going to P2V my desktop, so I'm going to put it in the data center for VDI. All you're doing is taking the crap you have on the desktop and putting it in the data center, so now you have a data center of crap. That's ultimately what you're doing at that point. You're taking the stuff that's down there, that's unmanaged, that was unsecure, that users install whatever they want, all these drivers that lived, and just moving it to a different location. So we can get away with a dual boot scenario where they can either select to go into the hypervisor to work, or they can select into getting into the native OS. However, the best course of action, rather than a P2V, is to figure out what you're really after. If you're really after things like the personalization, you're really after the things like you know, user customizations, the documentation, things like that. You don't really care about the applications that are installed. You don't care about the drivers installed. The best course of action, we have written an executable installer that has been successfully pushed out with SCCM. It's been tested with others as well. It can be used under some native Windows. In combination with SCCM, we used user state migration tool, the USMT tool, to pull everything off, push out the MSI package or executable. Now went from an MSI to an executable. It goes down, it carves out about 10 gigs of hard drive space, explodes itself into that, reboots the machine into that, installs, starts the download of the VM, registers automatically, and then we use automated scripts in the back end to push the USMT data back down. We did about 360 machines in just over 4 hours.
Yeah, we actually have a customized solution that uses USMT in the back end too for migration.
It's really the best way to do it.
In those two use cases, though, we don't necessarily want to do a migration. That's where it's a tough one, I know.
It is. We've thought long and hard about it, and the biggest thing is the P2V companies haven't written a tool yet that's going to do it, because there's so much badness on the endpoint in terms of device drivers that it's just going to, it's a very difficult task to hit right.
One other one.
Yeah.
The other one that we have a situation with in both of those use cases is the wireless connection.
Mm-hmm.
We may want a different connection for each of those VMs. And right now, that wireless connection is determined, and the SSID you connect to is determined in the hypervisor.
Correct.
Do you have any roadmap to tackle that problem?
Yes, we do. Yeah, we'll be, yes.
Yes.
We have a roadmap, yes.
Yes.
All right. Any other questions? Great. So feel free to download it. You can download it for free. You could try it. Just go to Citrix, try Zen Client. You can give it a try, see how it works out. It's pretty easy to deploy the synchronizer. We actually have it running on a laptop over there if you want to check it out. It doesn't require a lot of resources. You could take a small server and you could support a pretty large number of endpoints because it's all running on the endpoint. It's not running on that server. So you know, give it a try. And if you want to come by the booth, we'll be around for a bit if you have any other questions. And we also have some interesting programs going on right now for companies that are looking to do deployments where we can get you connected with some specialists who can provide some help, answer some questions. So thanks again for attending.